Now there is a special note that is for real extended object. If the image formed by single mirror is erect, it is always virtual. That is, M is positive. And in this situation, if the size of image is smaller than object, the mirror is convex, as shown in the left side figure. And if the image is equal to object, the mirror is plane, as shown by the middle figure. And the right side figure is indicating larger than object, the mirror is concave. So by observing the size of the erect image in a mirror, we can decide the nature of the mirror, whether it is convex, concave, or plane. For real extended object, if the image formed by single mirror is inverted, it is always real. That is, M is negative and the mirror is concave. In this situation, if P is P, if the size of image is, now three figures are again shown and all are the concave mirrors, and in the first figure, that is extreme right, that is extreme left, we will find that image is smaller than object is between infinity and C, and the image between F and C. Similarly, in the middle figure, we will find image is equal to the object. That is, size of image and object are equal, and object is at C and image is at C. In the third figure, that is the right figure, the image is larger than object is between C and F, and image between C and infinity. So these are the position of images for the various positions of object. As every part of the mirror formed complete image, if a part of mirror, say half, is observed, say converted with black paper, full image will be formed, but intensity will be reduced to half. So now it is again a figure of the concave mirror, and an object is shown between principal focus and center of curvature. The rays of light are moving from O. They are striking the mirror at the points of incidences and reflected back. The image will be formed I, that is inverted and larger in size and beyond C. If an object moved at a constant speed towards concave mirror from infinity to focus, the image will move slower in the beginning and faster in the last, away from the mirror. These facts I have already explained in the earlier lecture. This is because in the time object moves from infinity to C, the image will move from F to C, and when object moves from C to F, the image will move from C to infinity. At C, the speed of object and image will be equal. Now, this relation is given. Vi is the velocity of image, V naught is the velocity of object, and Vi is given as minus of V square over U square multiplied by V naught. Now we come towards the Newton's formula. The Newton's formula is indicated as T square is equal to x1, x2. That is, F square is equal to x1, x2. F stands for focal length, and x1 and x2 are the distances between the object and focus. And x2 is the distance between the image and the focus. Now we come to the application. There is convex mirror. The radius of this mirror is 50 centimeters. We are referring to radius of curvature. The image of the point at distance 50 centimeters from the pole of mirror on its axis will be formed at. So, four options are given. We have to check which is the correct option. So, to solve this question, we will take U as minus 50 because it is towards the left side of the mirror, and F is 25, that is towards the right side. So 1 over 25 is equal to minus 1 over 50 plus 1 over V. this we have applied the mirror formula, and from this we have made the subject of equation as V, and V is calculated by computing the numbers, and it came to be 15.3 centimeters. So the right option, that is V, will be 15.3 centimeters, that is 16 centimeters behind the mirror. So we have to check up which is the right option among the four. So figure is indicated here, object and the optical center 50, center of curvature and optical center is also 50. Hence the correct answer is D, that is 16 centimeters behind the mirror. So obviously it will be virtual image because it is behind the mirror.